Hello and welcome to this episode of Microchips, and on the bench today we have a Ham International Jumbo 3 that I bought, and let's see what surprises we find inside. Did I buy a lemon or did I buy a moderately good working radio? Anyway, before we start, don't forget to like, share, subscribe, comment, join Facebook, join Patreon, buy me coffee, have a look at my website microchips.net where all my boards are, and let's get started, see whether we can bring this old girl back to life. So yeah, Ham International Jumbo 3, and we all know these 3 series boards like to rot away, so I'm expecting to find lots of rot inside. So let's have a look inside. So immediately I'm greeted with a EPROM board. I can see cut wires, I can see ribbon cables, a strange wire that's running over the power supply. Yeah, this has been well lived in before. And there's some form of regulator strapped across one of the bulbs, and yet the usual rot is there, as we can see. So we will do the usual on that and recap the audio area. Now let's have a look around the AVR and the capacitor, and yep, the track is well rotted there. There's our lovely EPROM board, which will be coming out, and of course all the wires from the channel change to the PLL have been cut. The HC806 unit is missing. Now I thought somebody had linked this out, but it looks like it could be original. But yeah, our HC806 has gone, and the HC806 manages the 10kc and the reverse channels. So looking underneath, we can see where the wires have been soldered from the EPROM straight onto the back of the PLL chip. At least there's no cut tracks there, and we've got 3 legs of the PLL that are unsoldered, but they are actually connected to the EPROM. I don't know how 10kc ever worked on this thing, but yeah, anyway, let's check it, see what bands we've got. So this is channel 1 low band and mid band, and things don't seem to be working very well. It doesn't seem to be a frequency that I would expect, and -80 just drifts off into its own little world. The only thing that seems to work properly is UK40, which is on the last position. Everything else is completely up the wall. -80 is non-existent. -40 is, I don't know where. That's not correct for -40. That's definitely not right for mid-band. So yeah, we're going to have to investigate that. But yeah, as you can see from all the channel 1s, starting from UK40, the only thing that actually looks normal on this is UK40, and all the other bands are completely wayward. So we're going to have to sort that. So first thing on the list, let's sort out our leaky capacitor on the AVR and replace that, and then we will see if the track that usually rots is operational. If this track rots, it causes really strange effects. It's not actually directly connected to the AVR, it's just unlucky that that capacitor leaks and takes it out. So we're giving it a little wipe down, and I can see there is parts of the track still there. I'll just give it a scrape away. It's hard to tell whether it's still intact or whether this is the remains of what it should be. but we're going to have to continuity check that anyway to find out if it's still in one piece. It kind of looks like it is, but we'll wire link it out later anyway. Anyway, we will put a new capacitor in place, and we will take it from there. So I'm just going to do a continuity check across the trace, and we have continuity, so that trace is working, but we're going to link it out anyway just in case it goes strange. Anyway, let's start removing the capacitors around the audio amplifier. So luckily I've got a underside view of which terminals I need to desolder, so I don't need to keep flipping the radio over to check if I've got, or just to check if I've desoldered the right parts for the capacitor. I can just go over it. I've also got a diagram that shows me what capacitors go where from the top view, so it makes rebuilding these things a little bit easier. We can just go across and just blanket remove them. Anyway, we'll start plucking these capacitors out, and let's have a look under this 1000 mic, glued in with that lovely conductive glue, and we can see that there is a little bit of rot around that area. Some of these capacitors have definitely emitted their juices all over it, so we'll tidy that up and we will install new capacitors. But yeah, definitely rotten, but it's to be expected from these. Anyway, we've recapped it, and now I want to switch it on my bench power supply and check for anything getting hot using the thermal imaging camera, and nothing is getting hot. So yeah, everything seems fine there. That hot spot there is the AVR Darlington. Everything else seems to be okay, so we can assume that our capacitors are in the right way and none are overheating. Excellent, and we still have sound. So now I need to check if somebody's modified the channel change and whether there's 9 volts coming off the channel change going into the EPROM, which there is 9 volts, because the HC806 unit converts the 9 volts into 5 volts for the PLL, because if we put 9 volts into the PLL it's not going to be very happy. And of course these EPROMs are getting overdriven with 9 volts on the input, and we've got some voltages on the outputs, but we've seen 9 volts on the input, so we know that nobody's messed with the voltage to the channel change wafer. And I'm just putting the thermal camera on that trace at the front that got rotted, and as you can see it's warm, so it must be something must be, you know, strange with that track for it to get warm under use. But anyway, we'll link it out anyway. Maybe it goes a little bit higher resistance when it gets warm. Anyway, out with this EPROM. Now normally I'd go wild and start snipping, but we need to preserve the wires from the channel change on this, because we're going to attempt to put the wires back into the plug. So for these wires from the channel change, we are going to carefully desolder them, trying not to damage them any more than what they already are. And there we go. And this ribbon that goes off to the underside, we don't need that. So that's going to get snipped. Bye bye EPROM. Now let's carefully unsolder these wires that have been connected onto the back of the PLL. See what horror stories are under there. And luckily it looks like there's no cut tracks. And we'll get rid of that piece of ribbon cable. Now I'm just going to clean up the area with some isopropyl alcohol so I can have a good look at all those traces that come from the missing HC806 to the PLL. And everything looks just fine under there. No cut, no damage. Excellent. So now we need to find a 9-volt supply to feed the new HC806. So there's the 9-volt supply we're going to be using. There's a 13 volts input, and the 9 volts is on the white and pink. So we will use that in a moment. So now we've got to try and get these pins out of this plug. Now there should just be a little lever that we can press down and hopefully release these pins, and then we might be able to resolder the wires back onto them. So using a screwdriver and some tweezers, I can push down the latch and release the pin. So we'll do that with all the pins, and then we can hopefully pull them out. And there they go. They come out easily once they have been released. So we'll take all those out and put them to one side, and luckily whoever cut them has left colours on them, so we know the colour combination. I've already written this down. So what we're going to do is we're going to place one of the pins at the end of the tweezers. I've already opened up the strain relief on them, and we're going to solder the wire from the channel change onto these pins. So a little bit of a fiddly job, but we will take our time and get all these soldered into place. And as you can see there, I have my pin out diagram for the plug. So there's all the pins, and now we just need to put them back into the plug, following the colours that had already written down. So these just slide in nicely. There's a couple that were a bit awkward. Now I'm going to use one of my HC806 units that emulates the original HC806, and also on the back there we've got a link to put the -40 and -80 back to normal instead of reverse, and there's also an option to enable UK40 readout from high band. So a little bit better than the original HC806 because it's got extra functionality, but the downside is that we need to connect it to a supply to power the chip that's on there, and we're not going to be using the UK40 readout. We're just going to be using it to put the channel map back into place. Okay, so what have we got? So high band is a bit down. With the tune in the middle, it's definitely out. So mid-band is down, and minus 40 and minus 80 are exactly the same. So how could that be possible? Well, reverse engineering all this circuit is that minus 40 and mid-band use the same crystal, and minus 80 uses its own crystal. And we did find a strange crystal in there that shouldn't have been in there. I don't know why. Anyway, looking at this, we can see that minus 80 uses a 19.880, minus 40 and mid use a 2105, and then the rest are normal. So I've got my frequency counter connected to a place near the mixer where we can monitor the crystal frequencies, and we can see that 555 was okay, 2330 is a little bit low. Now we may have a lazy crystal. The KC shift does seem to bring it in, but when you have the KC shift in the centre, it's all the way at the end of its travel. So 2105 seems to be a bit high. Not sure how that could happen. Is it to do with somebody changing the padding capacitors around the crystals? Or do we have bad crystals, or is it a combination of both? Or is it to do with this on the back of the receive only tune? So there's two wires that are associated with it. We have an RX 8 volts and a TX 8 volts. And obviously the RX 8 volts allows the control to be used, and the TX 8 volts disables that and puts it onto internal. So we messed about with the crystals, and we have good working crystals with the correct frequency that we should be expecting. So let's have a look at the frequency counter again, and again minus 40 and minus 80 are exactly the same, and all the rest of the bands are absolutely fine. Mid band is fine, high band is fine, and plus 80 super high is fine. So looking at the output from the band select, we're seeing something that shouldn't be there, because on pin 2 we should have 9 volts on 2 of the bands, and pin 1 should be 9 volts on 1 of the bands, and what I'm seeing here is 9 volts on 2 of the bands. So it looks like somebody's messed with the band switch, and I suspect there's a link somewhere. Anyway, let's go to the schematic diagram and see if we can see this. So looking at the crystals, we'll just follow the crystal wires down on the schematic, and we can see that the crystal wires go to A, B, C and D, which is quite handy. So we'll go follow one of the wires down, follow it across to the band switch, and there it is. That's what we're looking for. So minus 80 has its own connection, minus 40 and mid-band are linked together, and that's controlled by the HC806, and that does the channel reverse, and that matches up with what I should be seeing with the crystals. So I'm expecting to see a link across the two end ones instead of mid and low, and I think it's there. I think that's it there, the brown wire, and the red wire is the next band across. So I think we need to move this link. So what we'll do first is we'll just continuity check the brown wire, just to make sure it is the brown wire that we want, and it is. So how we're going to attack this? Well, I'll just check the red wire first, make sure that that is the correct one. for -40 and mid, and it is. So that's definitely where we need to be looking. And whilst I'm in this area with the soldering iron, whoever's bodged a regulator onto the back of this bulb, yeah, I don't know why, I really don't, but it's coming off, it's gone. So we took the front off, and I've loosened the band switch, and I can just turn it round just enough to see where we should be connected. So basically the brown wire needs to be on its own, and the red wire needs to have the link for the two bands, and let the HC806 control it. So there's super high, high band, mid band, low band, and super low band. Excellent, the channels are now correct, and they are in the correct grid as well, not the reverse channels that Ham International like to do on this version of radios. Now I know it's not pretty on the back of the clarifier, but we've managed to reverse engineer all that and get that working as it should, because it was causing trouble when it was RX and TX and switched on and off. Anyway, we're going to replace the meter bulbs with cob LEDs. So I've modified the bulb enclosures. We've got a resistor in place, and I know they show very bright on the camera, but they are actually perfectly bright enough. We're going to change the antenna relay, courtesy of a design from haminternational.eu, which Steph gave me the files so I could produce them. And because this antenna board has got extra components and it's not the same as the Jumbo 1 and 2, I have had to put it on longer legs. I could design a smaller board, but there's no need when this works just fine. Maybe I will in the future, who knows. But for now, this is absolutely fine. Sits a little bit higher than the original relay, but it's inside. It's a good strong relay, good connections on it, so yeah, it's fine. And we will solder that into place, just like so. One more problem out of the way. Now let's do some performance mods. So, audio limiter. That needs to come out and be changed for a 3K, so two 1.5Ks in series, should I say. Or luckily I have got 3K resistors, so we will use a 3K resistor for this. So we will desolder said resistor, carefully remove it. You can see all my nice new capacitors around the audio stage there, so there should be no more rot around there. And we will put in our replacement resistor once it finally goes into place. We are also going to change another component as well to improve SSB sensitivity and receive. So this should help the SSB signals quite a lot. So out with this 47 ohm resistor, and we are going to replace it with a 150 ohm resistor, just like so. And whilst we are here, we're going to add the wire link to bypass that rotted track at the front of the board. And this wire as well, I don't know why, it was going to the microphone socket, but it looks unsightly. So we will replace it with another wire that's a little bit more fitting for this wiring that's in the radio. There's nothing wrong with the wire, it just looked bad. Anyway, excessive use of cable ties. We've got it looking nice and tidy as we can for a Cybernet chassis. Yep, not too bad at all. So let's check our 10692 and 10695, and they're a little bit out. So that's for USB and LSB carriers. So we'll set it to 10692 and 10695, just like so. Now checking the receive with a minus 72 dB signal, we can see that the S meter is a little bit generous, and we can also see that the control on the board is also very dirty. So giving it a little squirt with some cleaner, and that's looking a bit better. Now we'll set the AGC about 2.1 at 2.2 volts with no antenna connected. And again, the pot seems a bit twitchy, but everything, it seems to adjust okay. So we'll squirt a little bit of cleaner on that as well. Just checking the FM demodulator, making sure we've got a nice clean peaked waveform. And now we're just doing the SSB IF just to make sure it's as best as it can be. And yeah, that'll do. Now we're checking for carrier leakage. So we've got our scope on the output with no audio signal, and we're going to adjust the carrier leakage to bring it down to minimum, and that was quite a way off. So we've done that on the USB, and we'll switch it over to LSB, and it's about the same, so that's just fine. That's our carrier leakage as low as it can be. Just increase the magnification on the scope, get it down as low as we can. Fantastic. Checking the RF bias, we can see it's a little bit low, so we're on the base of the final output, and adjusting the bias potentiometer. It's all over the place, it seems to be very dirty, and just where you need it to be. It seems to jump all over the place. So seeing this is important, we will replace it. Now these are very small pots. As you can see, it likes to jump all over the place by itself, so obviously that's not good for final bias. So we will remove just like so. I know I unsoldered an extra one there, but I will resolder it. We'll take out the pot. As you can see, it's a very small pot, but luckily these have exactly the same footprint as those small pots, and actually fit in there not too bad. So we're back on the base of the final output, and we'll bring this up to around about 0.7 of a volt. So USB, no audio. As soon as it gets to 0.7 of a volt, it likes to jump up a little bit, but we'll set it round about 0.7, and that should be fine. As you can see, I'm having, there we go, just being a little bit twitchy. Okay, let's check the FM deviation. So I've got a tone being transmitted, and we'll set it to around about 2.5. That should be enough. Now, before we plug it into the mains, let's have a look to see whether the plug is wired correctly. And of course we have a 13 amp nail in there. So that's definitely coming out. And I don't have any 3 amps, so I will fit a 5. It's better than a 13 amp nail. We'll make sure all the screws are nice and tight, and everything looks just fine inside there. So we're powering it up off mains, 13.7.5 volts. That'll do just nice. No adjustment needed for its onboard power supply. I'm just having a look if there's any ripple coming from the power supply. And everything seems smooth, so I'm happy that that's in good working order. Now, before we fit the front, we're going to give it a nice clean with some foam cleaner. Once the foam cleaner's dried out, it looks beautiful. So let's have a look at our bands. So low band there, mid band 1 to 40, as you can see the channel map's correct. So high band and super high band, and something is wrong with the top end of super high band. And what haven't we done? We've not checked the VCO voltage, so we'll take it all apart again and have a look at the VCO voltage, and of course it's out of lock. So a little adjustment with a plastic tool that I've made, and we'll check it across all the bands to make sure we've got a even voltage. Or maybe not even, but a decent voltage on channel 1 super low and a decent voltage on channel 40 super high, which it is. That's much better. So let's try again. So super low band, we'll go to low band, perfect. Go to mid band, that's a high band, and super high band. There we go, just as it should be. Let's have a look at the power. So we've got 1 watt, 4 watts, and about 11 watts on the variable on the front. So that's nice. So some activity today. Sorry about the rumbling noise, it's my fan just getting caught on the microphone. So it's sounding lovely. So there we have it. My Ham International Jumbo 3 finally lives again with all its trouble that we've had to sort out. I think it's turned out quite nicely, and it certainly does receive and transmit beautifully now. Anyway, if you like this video, don't forget to like, share, subscribe, comment, join Facebook, join Patreon, buy me a coffee, have a look at my website microchips.net. Thanks for watching, and we'll see you in the next episode.